And now let us discuss about dispersion of white light through the prism. Guys, what do you mean by dispersion? See here, dispersion of white light means splitting of white light. Splitting of white light into its component colors. Into its components or component colors. Okay, so actually white light has millions of colors in it. Whatever light we see, no, the sunlight in the normal atmosphere, it is a combination of millions and millions of colors, guys. But for simplicity, we consider the white light is made up of 7 colors. Okay, can you able to tell the 7 colors of white light? We write it as ๊vyᴇʟᴏ. Yes or no? So what is this? Violet, indigo, blue, green, yellow, orange and red. So millions of colors which are present in white light is categorized into 7 different colors. Like all shades of violet, I will commonly call it as violet. Okay, all shades. Red has many shades, right? Light red, dark red, you know, all red shades I will commonly collectively calling it as red. Like that, we normally, for the simplicity, we say the light is made up of the 7 colors, but actually you will have the millions of colors in a white light. See, in a normal atmosphere, like the light we are seeing, the white light from a sun, we don't see these colors in a light, right? We just see the light as white in color. Actually, the light has these colors, but we don't see with our eyes. It's because, you know, all these radiations are traveling with the same speed in air. In vacuum or in air, all these radiations will travel in the same speed. They travel together in the same speed. That's the reason we don't see a single prominent color. They travel collectively in the same speed, no? So it looks like white in color for our eyes. Okay, but if I change a medium, like you know, prism is a glass medium. Yes or no? Prism is a glass medium. So the moment I pass this white light, you know, and if it hits on a surface of a prism, refraction of a light takes place. See, this white light is actually a combination of these colors and it is hitting onto a surface of a prism. And once the light enters into a glass medium, you know, it's a denser medium, much denser medium than air, right? And what I said, in air, all of them travel with the same speed. But in glass, they will not travel with the same speed. Okay, say the speed with which violet light travels is something different, and red light travels with a certain speed, blue light travels with a certain speed. You know, their speed of traveling will be different. Where in a glass medium. Okay, that too in a prism. In air, they travel with the same speed. That's why we don't see the distinct colors. We see them collectively as a white light. But in a prism, they travel in a different speed. Okay, say that's the reason this particular white light, you know, it splits like this. It splits into 7 colors. Splits into 7 colors. Okay, how many lines I have drawn? 1, 2, 3, 4, 5, 6, right? One more color, 7 colors. Okay, and you see they come out as 7 colors only. They come out as 7 colors like this. So this is how the refraction, bending took place. Definitely an incident ray which has hit, refracted inside, and emergent rays are also, they are coming out with certain bending. Okay, so this is our violet light, this is indigo, okay, and this is blue, green, yellow, orange and red. Okay, you see the violet light has bent the most. Violet radiation has bent the most. That means the speed of violet radiation inside the prism is less. That is why, you know, to more angle this deviation, to more angle you will observe the bending of violet light. Okay, and you know, the red light speed is higher even inside the prism. That's the reason you didn't observe much of the bending. If this is your white light, this is your red light. This is the line for the red light. You see, it did not bend too much, right? Because its speed of traveling inside the prism is much higher compared to the violet light. So for the violet light, you will observe more deviation, more angle of deviation is observed for violet light. Okay, but less angle of deviation is observed for red light. I mean, it has bended to a very smaller extent because it has traveled much faster even in the glass also. Okay, say all of them are traveling with equal speed in the air, but the moment they entered into a prism, their speed changes. Speed of traveling of violet is different, speed of traveling of red is different. So this is the reason splitting of white light is taking place inside the prism. Okay, and this splitting of white light into the 7 major colors is what we call dispersion. Okay, so what point you have to remember is why the dispersion, why the splitting takes place. Note it down. Splitting mainly takes place due to what, guys? Speed of the radiations. Speed of the radiation. See, these colors, I will call them as radiation. This is violet radiation, this is indigo radiation, this is blue radiation, like that. These 7 radiations together makes that white light. Okay, so what I have written, it is caused due to speed of radiation is different in prism. Okay, so here the speed is nothing but velocity, guys. Velocity of these radiations is different in the prism. So which one has the highest velocity? Red light has the highest velocity. That is the reason it did not bend too much. Okay, so next point is, the red radiation has highest speed or highest velocity, I can say. Highest velocity, so bending is less. Bending of red light is less. Whereas, violet light has less velocity, so bending is more. Okay, clear everybody? So that is the reason why violet light has shown more deviation and red light has shown less deviation. So this is what we actually mean by dispersion. Okay, one more point try to remember here. See, the wavelength range of this particular radiation is 400 nanometer to 700 nanometer. So, we all know the light travel in the form of waves. So, I am talking about the length of one wave. Okay. So, wavelength of violet light is lesser. Wavelength of red light is higher. Okay. So, more the wavelength. If the wavelength is more, it can travel much faster in a prism. What I meant to tell you is, if lambda increases, speed of traveling also increases. Okay, more the wavelength, with more speed it can travel in a prism. Since red light has more wavelength, so it is traveling more faster, so less bending, less refraction you have observed with red light. Okay, violet light has less wavelength. Okay, its waves are actually very much shorter. You don't have too much of wavelength. So that's the reason it has traveled little slowly inside the prism. So more bending, more refraction happened for the violet light. Okay, so this is your violet light refraction. Clear everybody? So this is a basic idea about the dispersion of light through the prism. And now, you know, these 7 colors are obtained in the form of a band. You are passing your white light from this side, right? The another side of the prism, you get a beautiful 7 colors arranged in the form of a band. You know, such a band of colors, we will call it as spectrum. So how do you define a spectrum? It is nothing but a band of colors. It is nothing but a band of colors, okay, which is beautifully arranged in a particular pattern is called spectrum. Can you able to give one example for natural spectrum here? Yes, rainbow. Rainbow is a natural spectrum which is caused due to dispersion of light only. Clear? Anyway, we will try to discuss about the rainbow formation little later. And before that, let us do an experiment, or let us learn an experiment done by an Einstein. Okay, actually Einstein is the first person to observe the 7 colors, the splitting of white light in a prism. Okay, and he wanted to know whether this splitting of light is a property of light or it is due to the prism. He wanted to know that. Right, so for that reason he has done certain experiment. Okay, what he has done is he took the first prism, he took 2 prisms actually. First one he kept it normal, erect one, and the other prism he kept was inverted. He took another prism which is actually inverted, right, and both the prisms he kept on side to side. And he normally passed, this incident, white light he passed, he has hit to the first prism, and as usual the splitting of light took place. Okay, he has observed the beautiful 7 colors splitting, and these colors he made it to pass through another prism. Okay, so in another prism they have traveled with a beautiful colors only, but when they were coming out of the prism, it came out as one single color, that is your white light. It came out as white light. Okay, so here he has given a white light, he has passed a white light to first prism, dispersion occurred, okay, refraction occurred, and these refracted radiations, this dispersed radiations again he made to pass through the second prism. Okay, but from the second prism when they were coming out, they have combined together and they came out as white light. This observation gave an idea about that the dispersion is a property of a light, it is not the property of a prism. Okay, just because the medium has changed. Say here outside you have a medium air. In air, what did I tell you? All the radiations will travel with the same speed. Okay, so that's why you observe all of them together and you will see that as white light. The moment it entered into a prism, you know what happened? It dispersed, splitting of light took place. And these radiations again he made it to pass through the prism. But when they were coming out of the prism, again the medium changes, no? Again when they go out into the air, like air, we all know in the air all the radiations go with the same speed. So again their speed becomes same and they travel together and it looks like a white light for us. So this confirms that this dispersion, the splitting of light in a different medium is a property of light. It is a nature of light. It is not the nature of some material like prism. Okay, only when the medium changes, like according to the medium, if the speed of these radiations changes, then this kind of splitting takes place. So this is what proved by this particular experiment by Einstein. Okay, and now let us see how this rainbow, a beautiful rainbow, can be formed. So guys, can you tell me when does this rainbow formation takes place in the atmosphere? So normally when you have both sunlight and a rainfall, rainbow formation takes place. But every time the rain comes, rainbow is not formed. Okay, it is because raindrops should have a particular shape, guys. Only then rainbow formation takes place. Okay, so imagine the sun is here. The sun is here. Okay, and you are standing here. You are standing here. Say the rain is coming. The rain is falling. and the raindrops shape should be something like this. You know, if you see this part of a raindrop, it looks like a prism. Yes or no? Yes, the raindrops should look like a prism. You know, the raindrops are actually tiny prisms. You know, that's the reason the dispersion is happening through these tiny prisms. If the raindrop is round in shape, you know, the dispersion cannot be observed here. Splitting of light cannot be observed. The raindrops shape should be something like this. See, upper part, if you see, it just looks like a prism, right? It should have a shape of a prism. Only then splitting of light can be observed. Okay, fine. So imagine, for simplicity, let me take the raindrop something like this. Okay, and what actually happens here is the rays, the sun rays would pass. Okay, the sun rays would pass onto a raindrop. Okay, and what happens, the medium changes here. Here you have a medium air, but this is your water medium, right? So the moment medium changes, what happens? Splitting of light into 7 colors happen. That's what I told you, no? The moment the white light enters into another medium, the speed of radiations changes. Okay, so because different radiations travel in a different speed, the white light here gets splitted up into 7 major colors, 7 major radiations. Okay, so what happens here is refraction would have occurred, and the light rays would have splitted like this into 7 colors inside a raindrop. Again here one more process occurred. What is that? See, these radiations, instead of going outside the raindrop, they won't go outside the raindrop, and instead of that, they reflect something like this. They start reflecting inside the raindrop only. This is what we call total internal reflection. Total internal reflection. So about this total internal reflection, you will study more details in your class 12. But right now, just try to remember, whatever the refracted rays have come inside the water droplet, they have again reflected. Instead of going out, they have reflected inside itself. Okay, and now these refracted rays will come and reach to your eyes. Okay, these are the 7 colored radiations. They are coming and reaching to your eyes. So you could see, where do you see the rainbow? If you project back all these 7 colored radiations, so here they will appear as rainbow for you. Okay, so when these refracted rays come and reach to your eyes, then you will see the rainbow backside. Clear, everybody? So this is the phenomenon how the rainbow is getting formed. So here the first step, what is happening here? The white light from the sun is reaching the water droplet, and what is happening in the first step? Refraction or dispersion is happening. Dispersion is happening. Yes or no? The white light is getting splitted up into 7 colors inside the raindrop. And again in the second step, what is happening here? Total internal reflection is happening. Okay, so all the 7 colors, instead of coming out of the raindrop, instead of refraction, what is happening? Reflection is happening. Okay, so the 7 colors have hit the surface. This is the first surface of a raindrop. Okay, at the first surface, dispersion took place, means splitting of light into 7 colors took place. Later, these guys are hitting at the second surface. This is the second surface of the droplet. But their reflection is happening, means again they are reflecting back onto the first surface. From the first surface, they are refracting, they are coming out and they are reaching to your eyes. The 7 colors are coming out, the 7 radiations are coming out and they are reaching to your eyes. Okay, so when these radiations reach to your eyes, these refracted rays, wherever they meet, there only image formation takes place. So if you drag this all the lines, they meet somewhere here, so you will observe the rainbow in this particular position. Okay, so this is how the rainbow is getting formed. Clear, everybody? Fine. And the position of a sun and a person is very, very important. When you can see a rainbow is, sun have to be behind you. Sun should be there behind you. Okay, and you know, the rainfall should fall in front of you. Say for example, sun must be there here, I should be standing here, rain must fall in front of me. Okay, only then, like behind the rain, I will observe the rainbow. You see, sun is behind the person, and in front of a person you have a raindrop. Okay, so in a raindrop all these things are happening. So where did you observe a rainbow? Behind the rain. Yes or no? Behind the raindrops you have observed a rainbow. So even in a waterfall, when you go near a waterfall, you will see a continuous rainbow behind the waterfall, right? So it's because, you know, you are standing in front of a waterfall. Imagine the sun is there behind you. Okay, from the sun, the rays are hitting the water droplets. Their dispersion, splitting of light is happening. Total internal reflection is happening. Again, the refracted rays are coming and reaching your eyes. So when you project back, you know, the refracted rays, whenever they meet, their image is formed. That image is formed. So the refracted rays that are reaching your eyes, now when you project back, you know, backside of the rainfall, you would observe a beautiful rainbow. Clear, everybody? So this is the phenomenon of rainbow formation in our nature. So how is the rainbow getting formed? First step is dispersion. Second step is total internal reflection that is happening inside a raindrop. And the third step is refraction. Yes or no? Refraction. So all these dispersed colored radiations are refracting and they are reaching to your eye. Right? When you project them backside, there the image of rainbow is formed. Clear? So this is how a beautiful rainbow is getting formed. So this is all about dispersion of white light through prism. Clear? So do subscribe our channel to learn the concepts in the easiest way and in a detailed way. Thank you so much.